So in preparing for this second formula, we're just going to look at what we have on this page and what we've already seen on this page. Those diagrams should look almost identical, don't they?
Yes.
Okay, so the diagram is identical. The difference is here in what we did yesterday, we thought about one point being x and one point being a, and then this difference between those was just x minus a. So when we looked at the slope, we had an x minus a on the bottom. What we're looking at now is we're saying this is still a, but now we're going to have a value for this length on the bottom, that value being h. Well, if this length is h, does it make sense that the x-coordinate over here will just be a plus h? Last time we looked at making our limit as x got close to a, so that that distance got really, really small and went away. This time we're going to look at what happens when we make the h equal to 0. Because if we make the h equal to 0, then it'll do the same thing. As we make our h go closer and closer to 0, that will bring this point down closer and closer, and eventually our secant line will become the slope of our tangent line. So again, taking this into consideration, we've got our rise and our run. Our rise is our difference in our y values, so that's f of a plus h minus f of a. And our run this time is just h. So we still make a formula for the slope of our secant line, and this time we make the limit as h goes to 0. And there's a little typo, I think, on your notes there. I think there's a 0 on the bottom. So if you just get rid of that 0 and change it to an h, so we want our h value to get to 0, and then we would find it. So again, the a is the x value at the point where you want to find the slope of the tangent. So we still have f of a and a. The f of a is the y value where you want to find the slope of your tangent, and the a is the x value where you want to find the slope of the tangent. So here's our first equation. We're going to use this one. This is formula 2. I can go back. That was fast. So I'll rewrite out that formula. Our formula for our slope is the limit as h goes to 0 of f of a plus h minus f of a over h. And we're finding it at the point 3, 5. So the 3 is our a, and our 5 is our f of a. So to find the slope at that particular point, well, our slope is the limit as h goes to 0. And what does f of a plus h look like? Well, a is equal to 3. If we plugged in 3 plus h into that formula, it'd be 3 plus h squared minus 4. I'll put that in brackets, minus, and we know that f of a is 5. So wherever there's an a, That's your x coordinate. And in this case, we're finding it at 3, 5, all over h. So now it becomes an algebraic manipulation question. We need to work through our algebra until we're no longer dividing by h, because we can't evaluate this limit right now, because if you plugged in 0 for h, you would divide by 0. So if we do a little bit of math on top, you can expand that. You're going to get 9 plus 6h plus h squared minus 4 minus 5 all over h. And wonderful things start to happen. Combine your like terms, and your 9s and your minus 4 and minus 5 all go away. And you can factor the top. You can take out an h, and you'd be left with 6 plus h over h. So now, oops, notation-wise, I forgot to write. We have to keep writing limit as h goes to 0 until you can actually apply that limit. So now that we've canceled out our h's, now you could plug in 0 for h, and you just get that your slope is equal to 6. And so now that we've got our slope is equal to 6, we know our slope is 6, our point is 3, 5. And again, I'll just remind you of both ways that you could find out the equation. One, you could plug in your slope, plug in your point when x is 3, y is equal to 5, and solve for b. Then rewrite your equation with your b value. Or you can plug in your point and solve. Either way, you're going to get y equals 6x minus 13. So things act the same way that we did with Formula 1. You're still plugging in an x value for a, and then you're using your algebraic skills until something cancels out to get your slope. Last time, usually it was a big factor that canceled out. This time, it's just the h's that are going to cancel out. So the idea is really the same as we had before. Once you've used your algebraic skills to cancel out the h and you get your slope, then you can go back and find your equation of your tangent with your point and your slope. Here is a square root 1. So we want to use our new formula, which is the limit as h goes to 0. Again, this is our a value. This is f of a, because we're finding it at that point. So our formula says do the limit as h goes to 0 of f of a plus h. Well, if I plug in a plus h, which would be 6 plus h, into our square root, we'd have 6 plus h plus 3 minus f of a, which is 3, all over h. Algebraic skills. What are we going to do with this? We need to get rid of that square root. How do we get rid of that square root? multiplied by the conjugate. So we're going to multiply, the conjugate of this would be the square root of 6 plus h plus 3 plus 3, and 6 plus h plus 3 plus 3 on the bottom. Because that creates a difference of squares on the top, and that simplifies things. Now, I wrote 6 plus h plus 3 again. Can you see that you could simplify inside the square root and it would just be 9 plus h? So in this next step, again, notation-wise, I keep writing the limit as h goes to 0. The difference of squares will be something squared minus something squared. The first one will be 9 plus h. The second one's going to be 9, all over h, times by square root of 9 plus h plus 3. So on the bottom, I don't multiply things out, because I multiplied by the conjugate to get rid of the square root on the top. I'm going to wait on the bottom because that bottom already has the h factored out, and that's the h that we want to cancel out. And now on the top, you see that our 9s are going to go away, and all we'll be left with on top is an h. And those will simplify, leaving you with just 1 on top. Now we can apply the limit. If I plug in 0 for h, I'm going to get square root of 9 is 3 plus 3, 6 on the bottom. And I get my slope to be 1/6. To find our equation of our line, we have our slope, we have our point, which was 6, 3. Okay, so I'm going to hand out some scrap paper for you now. Take 3 pieces of paper. I'll start some over here, start some over here. And the first one that you're going to be working on, using this formula, is 1 over x plus 3. Actually, for this 1 over x plus 3, I want you to do it with both formulas sort of at the same time, or do formula 1 first, then formula 2 second. And then I just want you to have a general which one you like better, because it's a new question. Try both formulas. So remember, formula 1 was the slope was the limit as x approached a of f of x minus f of a over x minus a. And formula 2 was the limit as h goes to 0 of f of a plus h minus f of a all over h. I want you to do this question with both formulas. And once you've done it with both formulas, you should get the same slope with both formulas. So if you get a different slope, that means one of them went wrong somewhere. Oh, I can't do anything. Okay, yes, sorry, the point is no, that's not the right point. That's the wrong equation. The point is at -2, 1. I'm going to put up the slopes so as you're going you can see how you're doing, and I will put up the last one, and then if you finish that, then you can go to your homework. 3x squared plus 5